Hey, good morning, everyone. My name is Jen. I'm a software engineering lead at Elsevier. And today I'm going to tell you some horror stories about QA. More importantly, how you can update your tooling, your workflow, and your infrastructure to avoid those situations. So who here is familiar with Tales from the Crypt? Awesome, a lot of you. So I loved the show growing up. This here is the Crypt Keeper who would open and close the show. And this show is actually based on comic books from the 50s and 60s. And I'm going to show you some of the artwork from that today, because I think that's also really cool. So first up, a little bit about Elsevier. Elsevier has been around since the 1600s, traditionally known as a publishing company. We are actually one of the world's largest publishers of medical and scientific content. We have a very large tech presence here in Philly, right at 16th and JFK. And I am also one of the organizers for Liberty.js, which is a JavaScript conference taking place here in Philly. It is our 6th year. Check out the website that was just launched this past weekend, and I have some stickers if you'd like to grab some after the talk. So let's talk about our first horror story, which is manual testing. I don't think I'll have to sell a lot of people on the horrors of manual testing here, but just to illustrate some of them, let's go through an exercise. So you have this email address input somewhere on your site. You know, customers need to log in or sign up. So how would you test this if you had to do it manually? You might want to, list out a bunch of different valid inputs, go through, enter them all, and make sure that these all work. But then you also have to input invalid inputs and make sure that these don't work, so that you don't lose customers in the process of sign up. So all in all, we might have, 24 total things that we want to test here that a manual tester, if they want to do a full regression test suite, have to enter every single time. So stepping back for a moment, I've worked on many different teams, some large, some small, some without QA at all, some with no testing, and some with a QA lead. Typically, that would be the liaison between developers and testers. Sometimes those were offshore, sometimes it was just a different department, but it always kind of bothered me that the developers and the testers never really overlapped or spoke to each other, and they would just pass defects back and forth. So what this leads to is a repetitive workflow where the tester tests a feature, they report a defect, then that goes up to the QA lead, they have to test it and validate it, then it goes back to the developer, and so on and so forth until it's fixed. So when you have a full checkout process and many inputs and fields that you need to test, this can get scary really quick. And luckily, in JavaScript, there has been a lot of automated testing tools around for quite some time. They all seem to have this common theme. I'm not sure why. But one of the tools that I really like that is just a couple years old is called Cypress. And if you're writing your front-end app in JavaScript using React or whatever, it also makes sense to write your tests for your front-end app in JavaScript as well. And so Cypress is different than a lot of these other frameworks because it comes with everything you need out of the box. You can just run one command and you're up and running. You can start writing tests and running them and you're good to go. So you don't have to worry about choosing different frameworks, installing Selenium or anything else. You can just run this one simple command and you're good to go. So here's what a simple page load test looks like. You just visit a URL, and then you expect a CSS selector to exist on the page. So this is pretty human readable. It's also really nice because even if you haven't written the tests, you can easily read through them and figure out what's going on. So to illustrate this, I made a simple ToDo app that we can run some tests on and see how this actually works. Because we all know how ToDo apps are supposed to work. We know what the functionality is supposed to be. So this should be pretty simple to test. And let me make this much, much bigger. So I am just going to start the site. And here we have it. So we just have the Crypt Keeper's little to-do list. So you can check things off, you can see what's active and what is complete, And you can also add things. Anybody want to shout out something that they want to add to the Crypt Keeper's to-do list?
Boil shackles.
Yes, boil shackles. So we can add something, and then we can also delete it if we want. So this is a pretty simple app, but I don't want to test all of those things that I just did every single time I make a change. So let's take a look at some Cypress tests. And let me make this bigger as well. So the first time you install Cypress, it actually comes with an example spec that goes through the full kitchen sink of their API, so you can actually refer to this and kind of look up everything that you need to do. You don't even have to visit their docs, but they do have great documentation. And I've left this example spec in here, and I'll share the link to all this code on GitHub later at the end of the talk. But here's our to-do spec. So we just have some tests. We have a list that we're saving as a variable up here, which is just a CSS selector. So we're saving this as list. And we're expecting it to have a length of 3 when we start up. Then we toggle one of the to-dos to incomplete. So we expect the checkbox to be initially checked. We click on it, and then we expect it not to be checked. And if you noticed earlier, I also have a little success message that pops in at the top and then disappears. And this happens in multiple tests. So I've actually saved this into a function above where we expect the success message to be visible. And then after a shorter period of time, we expect it to not be visible at all. And notice we don't have to do any waiting here. That's handled automatically for you by Cypress. So let's actually run those tests. Okay, so we see our example spec that came with Cypress out of the box. And here's our to-do spec. And here is Cypress running all the tests for us. So we can actually watch it go along. You can also run the tests headlessly, which we'll see in a little bit. But now I can confidently make any changes I want, run these tests, and make sure that the basic functionality of my site did not break. And if I want to, I can actually go back and step through each of these different tests. I can also see all of the routes that I've stubbed out. Since I'm expecting the starting state here to have exactly 3 items, I've stubbed out my API for the to-dos, and I make sure that it returns 3 items. And then, so when the site loads, the API has not loaded the to-dos yet, so it's empty. Then they eventually load in. And here we expect that the expected length to be 3. And we expect the first one to be checked. So let's see what it looks like if we're toggling something as incomplete. So here is the first one. We expect it to be checked, and then we can see Cypress clicking on it, and then we see that it is not checked. Then we can see that our success message is visible up here, and then that it disappears. So this is really cool that you can step through each test and see what's happening along the way. You can even open the dev tools and inspect if you'd like to as well. So cool. So Cypress really makes your testing dead simple. You don't have to configure anything. You can just install one command and get going. It gives you really readable errors and stack traces. You can also test responsive layouts by changing the viewport size, and they have really active documentation. So I highly recommend checking this out. That being said, if you already have a full suite of automated tests, you can try writing 1 or 2 in Cypress and see if it works for you. But as long as you have some automated tests running, that is better than nothing. But if you don't, this is a great way to start. And automated tests cannot do everything for you. So this doesn't replace testers' jobs completely. I will go over one of the products that we use at Elsevier later and talk about how our QA team actually transitioned from writing manual tests to Cypress tests, but they still do some manual testing. But putting the boring stuff and all the regression tests in an automated way actually frees up their time to do what they do best, and represent your site users and find unexpected functionality. And hopefully when they do that, they can go back and write a test for it so that it's covered under one of your test suites. Which brings us to our next horror story, which is mystery tests. So thinking back on that traditional QA and development workflow that we talked about, what typically happens is when the dev team and the QA team is totally separate, is developers work on a feature that goes into code review. If it's approved and merged, it only goes into testing at that point, which is a problem. Because I call this the throwing it over the fence method, because by the time if a defect is created and goes back to the developer, the context is totally lost. They actually don't know what tests are being written and run. They just get 1 or 2 lines that describe the defect, and then they have to go back and try to run it themselves. They can't actually fix the defect and run the tests to make sure it passes. So what can we do differently? Something that we've done at Elsevier is we've employed what is called shift testing left, which is we've just moved over testing so it's closer to development. So nothing actually gets merged into or deployed into another environment until the tests are all written, which solves a lot of problems for us. And it got the developers and QA to work a lot closer together, and they were actually able to, for a QA person that had never written scripting or tests before, they actually learned how to write some JavaScript from the developers, and the developers learned how to test certain things and write tests in a way that would test the site in a proper way, and so that they could write some of the automated tests themselves and share the burden of QA as well. But hold on. Isn't this going to take longer? How are we going to release on schedule? These are some of the questions that I always hear when we talk about this method. So I love this diagram that I took from Microsoft's blog. So no matter what sort of branching strategy you're using, I think this still applies, but let's say you have feature 1 and feature 2, 2 developers working on each one, and feature 1 takes a little bit longer than expected. So by the time it gets merged back into develop, feature 2 is already there. You get a little bit of merge conflict hell. And so your first round of QA goes in, and you put a round of fixes, and you have to release. So you release with some bugs, which requires you to do QA round 2, write more tests, and fix them, but you've already got some stuff in production. If we talk about the workflow that I just showed, all we're doing is shifting that QA portion over to the left. So you could still release at the same cadence if you want, but you would at least be aware of some of the bugs that you're releasing with up front, and you can make that choice consciously whether you want to release or not. So one of the products that we actually employ this workflow on is called Macro. Macro is a product for clinical researchers that has been around for over 20 years. So you can see a screenshot of the legacy application in the background here. We decided a few years ago to rewrite this into more of a SaaS solution. However, since this has been around for 20 years, and it's used by clinical researchers to not only design clinical trials, but also capture all the data associated with them, it's heavily audited. And it has to comply to many government and international standards. One of those standards is GCP, or Good Clinical Practice. And that just requires that you have a set of operating procedures that you adhere to, and that you can produce evidence that you've done all those things. This project has been audited multiple times by the MHRA, which is the equivalent of the FDA overseas. This product is used a lot in the UK. And in the bottom corner here is just a picture of our commercial manager holding one of the tough books that we configured and installed Macro on, which was sent to West Africa and used to test the efficacy of Ebola treatments. So sometimes we might be able to use this software as a service, but sometimes we actually have to send the product to the location where it's being used. But more importantly, we knew that in developing the new version of the product, we had to remain compliant. And compliance in the past, especially in regards to testing, actually looked like people printing out the manual tests that were run, and everybody who worked on it actually signing a copy, and this required wet signatures. And all of those documents had to be stored for a minimum of 25 years. So Iron Mountain would actually come to our office, pick up all of those papers, store them in a location, and they're off somewhere. Yeah. And when we are audited, any questions that would come up, we need to produce evidence that we have followed the procedures for all of those. So you can imagine how that might take a long time. And we knew that we had to adhere to these standards, but we wanted to do it a little bit better in the new product. So we actually used Cypress tests to accomplish part of that. So here is our definition of done, which is an operating procedure that we adhere to with macro, and we are happy to be audited on anytime. And the first thing that is listed is that we have all automated tests are added and passed before anything is considered done. And we actually store all of the output of all of our tests that are run. Everything gets dumped into Jira, so we can see for every single feature, all the tests that were run, who committed code, who signed off on it, and we can easily produce the evidence to show that we're following these procedures. So that has been working really well for us. And it's gotten a lot of the developers in QA to work closer together. But it hasn't been all smooth sailing. So one of the other horror stories that we have is unable to reproduce, AKA it works on my machine. So how did we fix this? Why does this happen, first of all? Sometimes requirements are unclear or incorrect. So either the developer is working on the wrong thing or the tester might be testing the wrong thing. Was your work even in the testing environment to begin with? I've had it happen multiple times where a QA lead might be managing multiple releases and not realize that something wasn't deployed to a particular environment. So the tester says this isn't working, and then the developer says that was never in that environment, and you go back and forth. And the last one is environment disparity. So different dependencies, user settings, and environment-specific changes. So a lot of times when we're developing locally, especially for the front end, we're running things in development mode, but we deploy static files to production. So that's one difference that we want to be able to test for. But if we think back to the workflow that I just described, we've actually solved some of these problems. If our requirements are written in the tests and accessible to the developers, then they're very clear. Either the tests pass or the tests fail. If you're doing you're adding all of your tests to the same branch before you merge that into any other environment, then it's very clear that you're working on the correct environment. But we still have this problem for environment disparity. And for that, we are going to dive into containers. So containers are small and lightweight, easily configurable. I'm sure many of us here use them or deploy to production in them, but we may not use them for testing locally or actually running our tests in a build environment. So let's go back to our demo and see how we can run that in Docker. First, let's run it in Docker in development mode just to illustrate how you can do that, and then we'll build up into running our tests there as well. So here is what our Docker file looks like for the ToDo App. So let's just walk through this line by line. So we have 3 different stages here. First, we have our development stage, and this is what I would want to, run locally on my machine if I was testing. So here we're stemming from the node version 10 image. This is pulled from the Docker public registry, and we're just calling this our dev stage. You can call these whatever you want. Inside the container, we set a working directory. I'm going to call this app. You can also call that whatever you want. And I'm going to copy in my package.json files into that directory, and then I'm going to run npm install. And I'm running npm install production here instead of just npm install, because within this project, I don't have that many dependencies. I just have a couple, the JSON server for my API and React is essentially it. And my dev dependencies just include Cypress. And I don't need to run Cypress when I'm just running the site locally, so I'm not going to install that for right now. And then next we have our build stage. So we're actually inheriting from our dev stage up here, but we're calling this build to start a new image. And here we're going to copy in our env files, we're going to copy in our entire source folder, and we're going to copy in the public folder. And here's where we're going to run build and actually compile all of our files that we would deploy to production. And then in our last stage, which is what we would actually use in production, we're actually going to use the nginx image. And we're going to start a brand new image here, and we're going to copy in our nginx config file. And then from the build container, the build stage, we're going to copy in our compiled files into the expected folder where nginx wants it to be. So now let's look at our Docker Compose file. So just to run this locally, I'm using 3.4 of Docker Compose. And I only have one service here. We're going to add some more later. It's just our UI service. So our target is the dev stage of the Docker file that we just looked at. By default, it will just look for a file called Docker file within the directory that you specify. The dot just means we're looking in this particular directory. And then I'm going to map some ports. So when we did npm start earlier, we know that the site was running on 3000. So it's also going to run on port 3000 in the container. But I'm going to map that to port 3333 on my local machine, just to illustrate the difference that you can set that to whatever you want. And I have the API running on port 3001. And then we are going to mount some volumes into the container. So if you noticed, in our dev stage, all we did was copy in package.json. So how's this actually going to run? This is where we can get our files into the actual container and have live changes run. So we're going to copy in our env files, our db, our source, and our public. And then when I make changes to within the source folder, they'll be automatically reflected when I reload the site. And the only command that is run is npm start. So first, I'm going to shut down the site that is running locally. And to run this, all you have to hit is docker compose up. And by default, this will just look for a file called dockercompose.yml. So we can see that it is starting up our site. And our JSON server is running in the background for our API. And now in the container, we can see that the site is running at localhost 3000. So if I load this localhost 3000, it is no longer going to work, because remember I mapped that to port 3333. And here we can see this all running. So if I was a new developer and I just started on the team and I didn't want to have to worry about installing Node or any other dependencies on my laptop, I could just install Docker, run that one command, which would download all the dependencies I need, and run the site automatically. Okay, so we've got that running, but we still want to be able to solve this problem of environment disparity between machines, and particularly when something goes wrong with our tests on our build server, I want to be able to recreate that on my machine locally. So how do I do that? So first, let's look at how I'm actually going to run the production site on our build server. For that, we're going to set up an nginx service, which is just going to target the prod stage that we looked at earlier, and it's going to run that on port 4000. In the container, it will be running on port 80, but I can access this on my local machine at port 4000. So in order to do that, I can run docker compose and then specify a different docker compose file, which I have called, I believe it's nginx, and then run up. And we're done. So the first time that you run any of these Docker Compose files, it will take a little bit of time to download everything, but because I've done this before, everything is cached on my machine, and you don't have to worry about me running this on conference Wi-Fi and you all waiting for it to happen. So now if I visit 4000, we should be able to see this is the production version of my site, and I'm no longer running my local API, so that's why there's no to-dos there. But if I inspect some of the JavaScript, you can see that it's all compiled and chunked out just as it would be in production. Okay, so now we can run it in production mode, and now we want to actually run our Cypress tests. So for that, we have a separate Docker Compose file, and we actually have a separate Docker file too. And we're going to utilize both the Docker file I showed earlier and this dockerfile.test, which stems from the Cypress base image. So Cypress provides you a Docker image out of the box that has all the dependencies that you need in order to run your tests headlessly. So we're just going to pull from that image, and we're going to set the working directory, copy in our package.json, and run npm install, which is going to install all of our dependencies, including Cypress. And then we're just going to run Cypress verify just to save maybe a second, since this will run each time that you run the tests. So then in our Docker Compose test file, again, we're using Docker Compose version 3.4, and we've got multiple services in here now. So first is our nginx service. We just saw this. This is exactly the same thing, except now we've added a network. So we've added an IP address that our tests can access the site running there at. And I've also set logging to none because I only want to see the output for my tests. I don't want to see any of the output or logs from nginx. So let's look at our tests service. So here, again, we are building from the dockerfile.test, and we're telling Docker that this service depends on our nginx container starting up. Depends on can be a little tricky with Docker because it's only going to wait for that service to start up. It is not going to wait for any commands to run. And this is on purpose. So Docker says that we'll wait for that container to start, but anything that happens in that container is your responsibility. And your services should be resilient to any failures. So if you need to wait for things to start, you need to have a script that will ping the service or wait for it to start appropriately. But since we're just running nginx, it starts up really fast. We don't really have to worry about that here. And we're also going to say that this service links to nginx so that we can access the IP address that we set below. And then we're going to set some environment variables. So we're going to set CI to true, since we use this within our build environment just to be consistent. We're going to tell Cypress that the base URL is this IP address, which is the same one that we've set below for the nginx service. And we're going to set video recording to false because I'm not saving those, so I don't need them. By default, Cypress will record videos for you and store them so that you can go back and watch all of the test runs. And I've set an IP address here for the service, although we don't really need it. And here we're going to mount two things into this container. We're going to mount our cypress.json file, just a really short config file, and we're going to mount the entire Cypress folder, which contains all of our tests. And then we are just going to do npx cypress run. So let's give that a shot. So here you can see all of the nginx output that I set logging to none for because I don't want to see all of this in my test run. So again, we're going to run Docker Compose. We're going to specify the Docker Compose test file and run up. Okay, so we can see that our nginx service has started before our test service because we told it depends on that. And now Cypress is running all of our tests headlessly. So first, it skipped over that example spec that came with the kitchen sink API for Cypress, which I've skipped because I only want to run my ToDo App tests. And here we can see all of those running. And they all passed. We can see that they took 13 seconds, no failures, and we're all good. Okay, and so we see that our test container exited with code 0, but the container is still running, like Docker Compose is still running, and I just want to grab that exit code and know whether my tests passed or failed. Because right now I still have to shut this container down. So in order to do that, you can actually just pass the exit code flag to Docker. And I've saved all of the commands that I've run today in this README so that you can check them out on GitHub later, and also so that I can easily copy and paste. So if I just want to grab the exit code from one service, I can specify exit code from, and then the name of the service, which here is tests. And let's run this again and see what happens. And we also get a nice little warning here that no logs are available because we set the logging driver to none. And you can also see that you get a nice little output of how many milliseconds each test takes. So you can see if one is really taking up more of your time, you can concentrate on trying to get that time down. Great, and we exited with code 0, so all is good, and the container is stopped, and we're all set. So now, if I see a test failure on my build server, I can actually pull that down, run it on my local machine, and debug straight from there. So just to recap a little bit, some of the things that we talked about are changing your tooling to use things like Cypress or just write some automated tests and make sure that they're available to all of your developers and that anybody can run them. And then changing your workflow to make sure that they're incorporated earlier on. And then you might want to make some changes to your infrastructure if you're not already using Docker to deploy things to production, to also use those on your build server and possibly on your local machine as well. Do I always develop everything in Docker? No. It really depends on the project I'm working on. So if it's a long-term project, I know I'm going to be working on it for a while, I'll probably take the time to install everything on my local machine. But if I'm just pulling down a new project, I want to try something out quickly, I will run it in Docker first. And if I encounter any disparities between myself and somebody else working on the team, Docker is the first thing I go to and say, can you run it this way, and test from there. So more importantly, you just want to see eye to eye with your team. And I just really wanted to use this photo. So you want to make sure that you're writing some automated tests. They're available to everyone, that you can keep testing as close to your development as possible, and that you use Docker for environment parity. And you don't have to do these in any order, whatever works for your team. As long as you're doing some of these, it has really helped our workflow. So with that, here is the link to all of the code that I showed. You can also find me on Twitter at VossGen. And if you're interested in talking about working at Elsevier, please come see me after the talk. Thank you very much. All right, and we'll open it up for questions. We'll go for in real life questions first, so if anybody wants to raise their hand. Yes?
So your test took 12, 13 seconds and you had 11
Yep.
tests. What happens if I have 1,000 tests and it takes hours for these things to run? Do I block code from going to production to wait for those things to happen in a continuous integration environment?
So the product that I described earlier, Macro, has many, many tests, at least hundreds. And if we run those headlessly, it probably takes about 5 minutes, which is still not an inordinate amount of time. And if we run those in the browser, it actually takes closer to 10 minutes if you're running the full test suite. But there are optimizations that you can make. Your tests should never take hours upon hours. You can also split those up into different sets. So if you want to run the full regression suite versus just your smoke tests, maybe you just want to run the smoke tests on every build and go from there. OK, so question 1. I'm a dev, and I write automated tests, but I'm not as good as coming up with test cases as QA folks are. Do you have both devs and QA folks writing automated tests, or only devs add tests for what QA reports for manual testing? So both of our devs and QA write automated tests. And it's a requirement, at least for the Macro project, that not only are automated tests added, but somebody other than the developer that worked on it actually runs a physical test of the feature that was being built. Because with things that like clinical trials, it's really important to make sure that the software works as we're expecting it to because treatment decisions are being made on the outcome and the usage of that product. So everybody writes tests. Anybody can write tests. And then there's also some, spot checking that is done as well. And how do you compare rate Selenium against Cypress? Good question. So I think the biggest drawback with Cypress is that right now it only supports Chrome and Chromium. So if you really have to test anything, if your primary user base is in Edge, Internet Explorer, anything like that, or Firefox, then it may not be the right thing for you. However, as browsers get closer and closer to more parity, I think it's not as big of a deal, but if you have to support a legacy code base, then you might want to stick with Selenium or something like Browser Stack. And how do you solve connectivity of your testing containers to a database? Or do you use mock data on the container? So a lot of times we do use mock data. Sometimes we will actually hit the actual databases, and sometimes that will require a wait to be put in Cypress. And that's partially because of the microservice architecture that we have, which uses eventual consistency. So sometimes we have to add a wait in order to make sure that those things come back within a certain amount of time. I would say it really depends on the test case itself of whether or not you want to do this. It's nice to actually add the option. You can easily comment out or skip the database mocking in your tests. Because if I want to just run this locally, I want to be able to not have to worry about connecting to any other database. And how do you handle data setup and teardown with Cypress? So that I can actually show you some. So Cypress has a lot of features that you can use that will set up and tear down and run things before your tests actually run. One of the issues that we had on one of our projects is handling auth0 login and making sure that users were either logged in or not logged in before the tests. And to do that, we actually just added some directives in this commands.js file so that we could add the appropriate authentication layer before the tests were run. And you can read more about this on Cypress's site. And do you run Cypress against production? Yes, we do. So for that, nothing is mocked, but it is a different set of tests that get run. It sounds like you are practicing Agile. Are your QA members are part of your teams, or is QA separated from engineering? So for all intents and purposes, our QA and devs are on the same team. However, organizationally, they are still considered a separate role. And I think that's going to be changing. Actually, one of our QA members just converted over to a software engineer. So as time goes on, it feels like that will be the process. But right now, we still have it organizationally separated. Any advice for multi-browser testing? So again, things like Browser Stack or Selenium are your best bet there, but really question why you need multiple browser testing and if that can just be accomplished by writing a couple tests that run in Chrome, or if you really need that. And have your Cypress-based testing practices passed an MHRA or similar audit? So we have not been audited with the new product by the MHRA yet, but we have hired outside consulting firms to audit us to test this in preparation for that, and those have all passed. And I fully expect that we will be audited. And when that happens, given the amount of time and effort that we put into this and the practice audits that we've done, we also have internal audits scheduled on a bi-monthly basis so that we're prepared and make sure that we have all the documentation and evidence that we need for it. And I think that is it. Have you ever encountered a bug that was reproducible in production but not in Docker? I have not. Has anybody here experienced that? Nope. How do you approach parallelizing a large test suite? Cypress actually handles this for you. So you have the option of running all of the tests in parallel or not if you don't want to. We do not do that, just because it was easier for us to get started that way. But you definitely have that option with Cypress. Yes?
So with like JS automated testing now, like a lot of your like CSS classes are structural. Do you like keep give like a separate CSS classes for versus like the ones that are purely stylistic?
Yes, we don't actually use classes. We just use attributes on the elements that are specific to the test selectors. Yes?
Do you have any challenges changing from the shift left approach or to the shift left approach?
So, yes, in that, so we've had a team, that's been working on this product for 20 years. Some of the developers were actually the original developers and had been around for a very long time. And they were not used to this new workflow when introducing, rebuilding the SaaS product. So it definitely took some convincing and getting used to. But once they were in the flow of it, things just kind of evened out and worked out well. So it does take some convincing, but luckily, I guess many members of our team were very supportive of it and willing to incrementally try things out to build this in from the beginning, and eventually people came around to it. Yes?
What's the integration with like your CI build tools look like? So if you fail tests, you usually get the video or see what failed through that?
So everything, like for audit purposes, everything gets pulled back into Jira, so all of our logs. But we have GitHub hooks. We use Jenkins for our build server, and we just run as our build script on Jenkins just that one Docker command that runs the same way that you can run it right on your local machine. And the tests, all the output gets pulled, and via GitHub hooks, that gets pulled, put into Jira, and the test output gets pulled and put into Jira too. Yes?
One thing is like the purpose of the automation is for the code coverage or different things.
Sorry, say again. You said the purpose of the automation is for?
Code coverage or defect detection, since we're running against production.
So I heard for code coverage.
Code coverage or defect detection.
So since we are not live with this new product yet, the word defect to us doesn't mean the same thing as it would when we are in production. But we do have a threshold for code coverage that we decided once we were a little bit further into the project that was the level that we wanted to maintain. But that's really flexible depending on what your project is. So it's a little bit of both. You want to maintain some code coverage, but you also, don't want to release defects. So when you're writing the tests, it shouldn't be like, oh, I'm trying to up my code coverage. They should have a purpose and test something that you wouldn't want to go back and test manually, but you want to make sure it doesn't break. Thanks. How do you solve connectivity of your testing containers to a database? Oh, we covered this one already. I think that might be it. And I think we're just about at time. So thank you very much.